Today's lesson will be about multiplying probabilities. Please don't forget to put your date in the upper left corner and log page 4 in the upper right corner and multiplying probabilities on the first line. Today we're going to talk about compound events. A compound event consists of two or more simple events. Simple events are what we talked about last week. When finding the probability of compound events, we first must find the probability of each simple event. So we're going to review what we talked about last week. The multiplication rule is going to help us to find the probability of a compound event. To find that probability, we multiply the individual probabilities of each simple event. The multiplication rule states that the probability of A and B happening is equal to the probability of A times the probability of B. Remember, the word and is called the intersection, and we also learned this symbol to mean and or intersection. Example 1. Rahim chooses a soda from the cooler. The cooler has 8 regular and 5 diet drinks. He decides he doesn't want that one, so he puts it back. What is the probability that Rahim and the next person both choose a regular soda? Well, first of all, let's look at our simple events. The first simple event is that Rahim chooses a soda. He chooses a regular soda. So this is the probability that Rahim will choose a regular soda. Let's review from last week how to find the probability of this simple event. There are 8 regular sodas in the cooler. There are 13 sodas altogether. 8 plus 5 is 13. So there are 13 sodas altogether. So the probability that Rahim will choose a regular soda is 8 out of 13. What is the probability that the next person will also choose a regular soda? Well, Rahim put the soda back, which makes these events independent because the next person's choice is not affected by Rahim's choice. So there are still 8 regular sodas and 13 total sodas. So the simple event of the next person choosing a drink that is regular is still 8 out of 13. Now, the multiplication rule tells us that we can find the probability of these compound events by finding the probability of Rahim choosing a regular soda and the next person choosing a regular soda simply by multiplying these two probabilities. Because these are the probabilities of the simple event. So 8 over 13 times 8 over 13 is 64 over 169. Well, except you can't see the 64 out of 169. Let me pull this up just a touch so you can see all of that. There you go. Let me move it the right way. There it goes, right there. So the probability that Rahim chooses and the next person chooses regular, you multiply the probability 8 over 13 times 8 over 13 equals 64 over 169. Why is this independent? Because Rahim replaced the soda, and the second person's choice is not dependent upon his choice. We could make a tree diagram for this same problem and illustrate the probabilities right on the tree diagram. So that's what we're going to do. So we have Rahim choosing a soda. And he can either choose a regular soda or a diet soda. If he chooses a regular soda, the probability that he chooses it is 8 out of 13 because there are 8 regular sodas in the cooler, and the probability that he chooses a diet soda is 5 out of 13 because there were 5 diet sodas. The next person comes along and will choose either a regular or a diet, and the probability that they'll choose a regular is 8 out of 13. The probability that they'll choose a diet is 5 out of 13. And if Raheem chooses the diet soda, then the other person still can choose a regular, that's 8 out of 13, or a diet, and that's 5 out of 13. Now what we can do is we can figure out what the probability is of the compound events, because the first simple event is Raheem choosing, the second simple event is the next person choosing. So now we can find the probability of the compound event. What is the probability that Raheem will choose a regular and the next person will choose a regular? We're going to multiply these two probabilities to get 64 out of 169. Raheem chooses regular and the other person chooses diet. That's going to be 40 out of 169, multiplying 8/13 times 5/13. What's the probability that Raheem chooses diet and the other person chooses regular? That's 40 out of 169. What's the probability that they both choose diet? That would be 25 out of 169. 5/13 times 5/13 is 25 out of 169. Total probability. The total sum of probability of a sample space is always 1. To find the complement means the probability that an event will not happen. To do that, we subtract from 1. And the symbol for complement is A with the little superscripted C. Let's go back and look at Raheem's problem. The sample space for Raheem's choice is the regular and the diet. So we're going to take 8/13 and 5/13 and add them together. 8/13 plus 5/13, and that's going to give me 13/13, which is 1. The probabilities of any sample space always add to be 1. The sample space of the second person choosing a diet or a regular would be here and here, because the second person can choose a regular or a diet, and that would be 8/13 plus 5/13, which would be, again, 13/13 or 1. Same down here. 8/13 plus 5/13 would give me 13/13 or 1, because this is the sample space for the second person choosing a regular or a diet. Now, if we want to look at the sample space of both simple events occurring, the sample space of the compound event is this whole tree diagram. So we would have to take 64 over 169 plus, scoot this way, 40 over 169 plus 40 over 169 plus 25 over 169. And when we add these together, we get 169 over 169, which is 1. So the total of the sum of the probabilities of the entire sample space is always going to be 1. If you're looking at the simple events, those probabilities will always add to be 1 as well. Example number 2. In a certain board game, 3 dice are rolled to determine the number of moves for a player. Find the probability that Consuela rolls a 6, then another 6, then anything but a 6. So what we're looking for here is the probability that Consuela will roll a 6 and another 6 and anything but a 6. So anything but a 6 is the complement of rolling a 6. So we have to find the probability of each of these simple events and then multiply them together. So the probability that she'll roll a 6, there's 1 6 on a die out of 6 numbers, so that's 1 out of 6. The probability she rolls a 6, 1 6 out of 6 numbers, and then the probability that she'll roll anything but a 6. She can't roll the 6, but she can roll the 1, 2, 3, 4, or 5. So there are 5 numbers that are not a 6, so the probability of rolling anything but a 6, which would be the complement of 6, is 5 out of 6. So we're going to multiply these together. 1 times 5 is 5. 6 times 6 times 6 is 36 times 6, which is 216. So the probability that she will roll a 6, and then anything but a 6 is 5 out of 216. Example 3. 12 marbles are in a bag. After each draw, the marble is replaced. There are 6 yellow, 2 blue, and 4 purple marbles. Find each probability. So we want to find the probability that we will pick a yellow and a blue. Well, the first thing that we need to do here is find the probability of a yellow. Since there are 6 yellows in the bag and there are 12 marbles altogether, the probability of drawing a yellow is 6 out of 12. And then we're going to multiply that times the probability of pulling a blue. Well, there are 2 blues out of 12 marbles. We know there's still 12 because it is replaced. So that's 2 out of 12, which will give me 6 times 2 is 12. 12 times 12 is 144. So the probability of pulling a yellow marble and a blue marble on the next pull is 12 out of 144. Now we need to find the probability of a purple and a blue. Well, now let's find the probability of drawing a purple marble. There are 4 purple marbles out of 12. So 4 out of 12 times the probability of a blue, which we've already found right here, is 2 out of 12. So that would be 8 out of 144. Now we want to find the probability that we will draw a blue and a yellow and a purple. Well, the probability of a blue is 2 out of 12 times the probability of a yellow is 6 out of 12 times the probability of a purple, which is 4 out of 12. 2 times 6 is 12 times 4 is 48, and 12 times 12 times 12 is 1,728. So the probability that we will pull a blue and a yellow and a purple is 48 out of 1,728. Now, our next example is a tree diagram, and it asks us to find the missing probabilities. So, we're going to look at the first event. 0.45 and A. Well, these two must add to be 1. Let me scoot this over so you can see it again. So I have to take, in order to find out what A is, I must take 1 and subtract 0.45. And when I do that, I get 0.55. So A is 0.55. Then the next event has 0.16 and B. Again, this is the sample space, and I'm scooting so you can't see again, sorry. Okay, so 0.16 and B have to add to be 1. So in order for me to find what B is, I'm going to take 1 minus 0.16. And when I do that, I'm going to get 0.84. So B is 0.84. Looking down here at the other choice for the second event, I have 0.32 and F. Again, I can take, because this is a total sample space, 1 minus 0.32, I can subtract that in order to find out what f is. And when I do that, I'm going to get 0.68. Now that I have found those numbers, I can multiply 0.55 times 0.68 to check to make sure I've done this correctly, because 0.55 times 0.68 by the multiplication rule should give me the 0.374. To find E, I'm going to do the same thing here. I'm going to multiply 0.55 times 0.32, and in order to do that, I'm going to get 0.176. This is the multiplication rule that says if this happens and this happens, to find the probability, I multiply the probability of the simple events. 0.45 times 0.84 gives me 0.378, and 0.45 times 0.16 gives me 0.072. I hope this has helped you. Please be sure that you are prepared to ask questions.